Yeah, I think because there's not that much time and we have lots of competitions, we'd probably rather just start now, and then at some point Julian and the others will join us, I hope. So, yeah, my name is Mike Preuss, and I'm chairing the competitions this year together with Julian, and we have quite a lot of competitions. And by the way, we have a new conference logo. I put it in large over there. That is going to stay, as I understand, Diego, for the next conferences. So we try out a little bit of a different program this time because I don't want to bore you all with, let's say, 10 presentations of 20 minutes each, and then you will probably all be asleep. So what we try out is we cut the session in 3 parts. In the first part, we have short talks by the 6 competition organizers about their competitions, 5 minutes each. So I hope that works out. It's barely enough to just tell the basics about the competition and relate the winners, if they are already there. Then we will have a panel discussion led by Christoph Salger, who is hopefully going to come soon. So we have some time until that happens. So we have some people who have been asked to sit here on the chairs and are going to be asked critical questions about competitions. And then we have a second block of competitions. Actually, the second block has only 5 competitions, so I made a mistake there. And we also have the short video competition, but that is not going to be presented today. It would not fit anyway because the videos altogether are too long for the session. That is going to be presented on Thursday, and I presume it's the last slot on Thursday. So, and what we try to invent now is that we also have a poster for each competition, if the organizers made one. So I asked the organizers to make a poster, and we will have the poster session just after this session. So the idea is that the organizers now give you a rough overview of what the competition is about, and then you can go to the poster in the poster session and ask the organizer about the details. So I think in that sense you can focus on the competitions you like, and you don't have to hear all the stories. That would probably take too long. So I hope this works out. And so what you need of us is an order, and we have tried to do it in the same, basically in the same order as is on the web page. With one difference, Diego told me that he wanted to be in the second slot because he needs some organizational stuff, needs to do some. So in principle, I hope you can memorize that. I can also put it on the screen in between. So it's exactly resembling the order on the web page, with the exception of the GBGAI. So the first guy to start would be the Angry Birds level generation competition. Is somebody there to present it? I hope so. Ah, okay. So we shall change the order because. Okay. Now, would that, yeah, Niels is there for the butt ball. Then I just switched the order.
You can.
Ah, okay. Matthew, are you ready to present your competition now already? Or?
I can.
Don't get too angry now. Please try to keep it to 5 minutes.
Yes.
So here's the cable.
Thank you.
Oops.
Not there yet. No one's saw. It's okay. Shall I go? Or? Yeah. Okay. So yeah, I'm presenting the results from the 4th Angry Birds level generation competition that we held this year. So a little bit about the competition. It's about designing level generators for Angry Birds. It's organized by myself, Jochen Renz, Julian, and Lucas Ferreira. And this is a joint competition that's held with the Angry Birds Agent competition, which focuses more on developing agents for playing Angry Birds. And playing Angry Birds is actually a very difficult task for AI. The agent competition's been running for 8 years now. We had the 9th competition just a week ago in Edgecombe, and agents are still nowhere near reaching human level performance in this game. So level generation is a very important tool for generating training data for reinforcement learning algorithms. So we had 5 generators that were entered this year. We had a naive baseline generator that generates just basic levels comprised of a single structure. We had the funny quotes featuring dominoes generator by Jiang Yuxuan from Ritsumeikan University in Japan, and this generates levels that form quotes or formulas. We had Fitra by Febri Abdullah, also from Ritsumeikan University, and this generator creates levels in the style of a Rube Goldberg machine, where you have to try and find one shot to clear the level. We had the Bambird generator by Thilo Martens from Bamberg University in Germany, and this generator creates random levels and evaluates their quality using the Bambird's agent. And lastly, Melody Gen by Seren from CoG University, I think, from Turkey. And this generates levels by translating music patterns to structures. So in terms of how we evaluated the levels, we generated 50 levels from each generator and then randomly selected 4 from them to be evaluated by a panel of 9 independent judges. And so these levels were evaluated for 3 different criteria: the fun or enjoyment that you had when playing that level, the aesthetic or creativity of the levels, and then also the difficulty balance of the levels. And so the sum of the scores across all these categories determine the overall winner of the competition. So here we have the results from the fun or enjoyment of the levels. Melody Gen won, Fitra being second, and Naive being third there. In terms of the aesthetic, we had Fitra as first, Melody Gen as second, and then Funny Quotes as third. And in terms of difficulty balance, Melody Gen was first, Funny Quotes second, and Fitra third. So if you're good at maths, or you just saw them before, the overall results, with Melody Gen winning, Fitra second, and Funny Quotes third. And this is the overall rankings, and that's it.
Quite strict on time, so we don't have any questions now. You have to ask him in the first session, so there's enough time to ask the competition organizer.
Okay, so I will present the board bowl. It is the board bowl 1, so first time we have this competition. It's based on a board game called Blood Bowl, and the idea comes from, like, now we have achieved like superhuman level in the board game Go, and we hear sometimes that now AI is done with board games, but I don't really believe that. There are many board games that are much more difficult than Go. So we found this game called Blood Bowl, where you have up to 11 players on the field, and you can move all of them on your turn, and each figure can be moved several times during the turn. So it's a very complex game. You can come to my poster session where I'll talk more about this, and I can show you some of the games in the competition, and I'll also present our competition paper on Friday, so you have many chances to learn about this. We use a client that we made in Python with some A-star functionalities for scripted bots, but you can also train reinforcement learning agents with an OpenAI Gym interface. We had 4 entries in this competition, and then we also added our random baseline into the mix. We had one called A2C, which is the deep reinforcement learning algorithm A2C, trained with reward shaping. A similar one called No One, also A2C with reward shaping, but with the addition of first training against a random agent and then training against itself. Then we have GrotBot, which is a scripted bot using A* a lot and a great deal of knowledge about the game. And it's based on 16 constants in the code that prioritize which types of actions it should perform at every step. And then we have EvoGrot, which is an extension of GrotBot, where these 16 constants are evolved using evolutionary algorithms. And then we have some money prizes for this competition, and the threshold is that you beat the random baseline, which is the best we had before the competition. And if you in some way improve or build on other code, it must be an interesting or significant extension. That's prizes. So first we had a round robin tournament playing 10 times against all the other bots, and the best two will then go to a final series of 5 games. So here we have the A2C, which maybe it's a bit difficult to see, but it had 10 ties against the random baseline. So on the right side of this column, you can see the number of wins. Then we had No One, the reinforcement learning bot, winning 5 games and tying 5 games against the random. And the two best, GrotBot and EvoGrot, which have very similar performance, but GrotBot winning a bit more. So these two go to the final series. And the first game was, can you see this? It's a bit delayed. So it's a best of 5, and GrotBot is winning the first 2. It's a tie in the third, and the fourth game is also won by GrotBot. So GrotBot will be the winner, and EvoGrot will be the second place. And going back to the round robin tournament, the third place is the No One, the reinforcement learning agent. And we will publish these matches with commentary soon, and hopefully also have a human playing against GrotBot. And you can watch the games at the poster session. I don't know if I have much time left. No. Okay. I'll talk more about this at the poster session. Thanks.
Okay, fighting game AI competition, Rak Tawan Mas. The poster will be presented by one of my colleagues, Tomohiro Harada, at the poster session. So Fighting Ice is our original game developed in Java, also a lab for Python. So game resources are from real game companies called DIMS that develop some action fighting games in Japan. And our aim is to try to come up with a way to promote research on general game AI, in particular general fighting game AIs, which mean AIs that are strong against any unseen opponents, and environments, which mean character data or play modes. And so there are some features like the very short response time is 60 FPS, and we intentionally introduce delay. So the latest game state has a delay of 15 frames, and its current version is equipped with a forward model and a method for assessing screen information if you want to train this with deep learning technique based on visual information. And recently, we have provided an OpenAI Gym API. And why this platform? So according to our experience, mainly for my students' experience, they still couldn't come up with strong deep learning techniques. Probably we don't have that huge infrastructures as Google. Okay, so deep learning still does not prevail yet. Maybe because generalization against different kinds of opponents might be a challenging issue for this. And also a very short response time plus intentionally introduced delay might be challenging factors for even MCTS, in particular if they have to fight against expert human players. We plan to do this in Osaka next year. And we have some academic papers on using this platform to by author groups as shown there, and to by our group in this conference. One is about MCTS highlight cues for generation of entertaining gameplay with oral presentation, probably tomorrow. Yeah. And the next one is poster. It's about using this platform for as a gaming for motion gaming for physical health promotion. Contest. So there are 3 tournaments, and we divide into 2 leagues. One is standard, and the other one is speed running. Okay, and we have 3 characters. So Zen, Garnet, Lat. The first 2, all of their data are available beforehand, while the Lat one is not revealed in advance. So meaning that you need to train beforehand to adjust your AI towards this character data. And we have 9 entries from 8 countries, and we put our sample MCTS, open loop MCTS for reference. And here are techniques in use by the submitted 9 AIs, 3 just multiple heuristics, and 2 AIs use a combination of MCTS plus heuristic rules. Heuristic rules for selection of rules for MCTS to search. And 2 using Minimax, and for unknown character data they use MCTS. And 1 use genetic operations again for pre-selection of rules and then MCTS. And the last one using Mori horizontal evolutionary algorithm plus opponent modeling. They use some deep learning Java tool for doing that. And results, you can see that the orange one is the first, and the blue one is the runner-up, and the third is green. And you can see that now our winner is Reva Thunder, which has won this competition for 4 consecutive years. And the runner-up is a new team from China using rowing horizontal evolutionary algorithm. And that's it. Actually, I have some videos, but please come to our poster for seeing this video. Thank you.
Okay. Hi everyone, I'm Adam, presenting our competition First Text World Problems on reinforcement and language learning in text-based games. So FTP, First Text World Problems, was a research competition aimed at teaching machines to play text-based games, but our ultimate goal was actually to teach machines to interact with the human world. So we know that RL is a great framework for teaching machines to interact with environments generally. And similarly, the tool of language is what people use to interact with each other and with much of our world. So the nice thing is that text-based games combine RL and language, and that's why we pose this particular competition. So for anyone in the audience who's a bit younger, this is what a text-based game looks like if you haven't seen one before. This is the opening scene of Zork, which is like the canonical text-based game. As you can see, the player observes the world and the game state through text descriptions, like on screen, and the player takes action by typing short text utterances. The world changes according to these player actions, and text describes these changes as well. So anyone who's played these games probably knows they're pretty challenging, even for humans. So AI, currently is pretty terrible at them as well. Okay, so here's an overview of the competition. The overall objective was to train an agent to solve a suite of simple text-based games. And these games share an overarching theme and objective, but with individual variations throughout. There were over 4,000 training games, over 200 validation games, and over 500 evaluation games. Progressing through these games, progressing through sub-goals in the games earns your player your agent points, just like in normal text-based games. And the final assessment is just collecting all the points earned on the hidden set of evaluation games. So agents, just to simplify things, because text-based games are so hard, agents can request additional state information from the game engine, but this leads to a handicap, which lowers your final score through a multiplier. So the competition ran from January to July of this year, and hundreds registered, while about 16 teams participated actively. So we generated the suite of simple competition games using Microsoft TextWorld. This is a simulator and procedural generator for text-based games that my group built as a research platform. It's open source if you're interested in playing around with it. You can check it out on the link on screen. And it's also compatible with OpenAI Gym. So the games, what do these simple competition games look like? In all of them, the player finds itself hungry in a simple modern house with the goal of gathering ingredients to cook a meal. The objective is stated in the form of this recipe that the agent finds in the kitchen, if the agent can get to the kitchen. So on the right, there's a schematic depiction of a competition game. It shows the map and the recipe, but note that the map is never seen by the agent. It has to understand the world through text only, and so it has to go through the different rooms and find these ingredients listed, bring them back to the kitchen, and that's how it earns points. The key thing is that the recipe, ingredients, and the house layout, they all change from game to game, so agents have to generalize rather than memorizing a single step-by-step procedure. Okay, so here are the results. I've presented here the scores and some of the model details for the top 3 submissions out of 16 total. So the listed score there represents the percentage of maximum points possible that an agent earned on all of the test set games, all 514 of them accumulated. And I'll say now congratulations to our winner, Pedro Lima from Portugal, who's not here right now, but you can all celebrate him anyway. In addition to his cash prize, he'll also feature in an MSR blog post coming up soon, which you can also look at if you want to learn more about the competition and his agent. As well, I have the poster, of course, later. So his victorious agent used a clever combination of fine-tuned BERT modules for language understanding and some optimism in the face of uncertainty to learn its policy. So that's BERT and UCB1, which is a bandit algorithm that balances exploration and exploitation. So what did we learn hosting this competition? First, that representations from pre-trained language models like BERT are effective in RL settings. Second, that compositional action spaces like text utterances can be tackled by mixing generation with structure and constraints, which is what Pedro Lima did. The winning agent's capacity for state tracking and planning was pretty limited, but that's because the competition games themselves were fairly simple, so we might host a more complex competition in the future. And we'll release the full competition suite for future research. So thanks very much for your time. There's some informational links on screen if you want. If you want to learn more, please come to the poster or email the TextWorld team. Thank you.
Okay, so The Geometry Friends competition is a framework that we are developing to foster collaborative AI. And our main goal is actually to have agents that are able to interact with people through this game and have teams of agents and players. Since it's not a game that is widely known, I have a video to show you the gameplays. We have two characters. They are totally distinct in the capabilities they have in the game. They move around in the 2D physics-based game, and they have to collect some diamonds. So they have these two distinct characteristics. One can roll and jump, and the other can only slide and change the shape. And the world has some physics, which means it's kind of a continuous action space with some realistics. We use a game engine for the physics, with mass, spin, all these matters for the interaction of the two players. They have platforms they can collide with, depending on the color, and they have to collect all these diamonds in the least amount of time. Okay? And by having different levels, we have different kinds of challenges. What we give you as information in the sensors for the AI, this is actually a very small environment. You have access to everything, including screen pixels if you want. And you control these agents through a force kind of control, on and off switches of forces. We have a few tools for modeling, level editor, and online submission that computes the results automatically. So why we found this interesting for our work is that this combines collaboration to different levels. It is a task plan and motion planning that is often discussed, at least in robotics, AI and robotics. And they are two different things, because one is more search-based, writing a plan that works out, and the other one is more control-based, that you need to figure out all together to solve the task and do all this in real time. So we have 5 submissions. This is divided in 3 tracks, 2 individual, one just for the circle, you see, one just for the rectangle, and one collaborative. So we had as baselines the winners from 2017, and this year all of the submissions, or at least the winners, beat the baseline, which is actually good. For example, this one used search-based planning with abstract space for the planning part, and control policies crafted a bit by hand to control the agents. This one was built on top of the winner of 2017 for the circle and was adapted for the rectangle, which is A-star search and Q-learning for the control. And for the first time, we have actually a cooperative agent that is able to solve something meaningful. It's the first time, although the levels probably are a bit simpler this year. And we had 3 submissions for the cooperative. We're still handling with the issues from one from Taiwan. So we put this. And this is the type of things they need to solve. I think my time is running out, so I'll have a poster. I can talk to you for 2 hours. It's very interesting. Thank you.
Can I borrow a machine? How do I sign?
You need a computer?
Yeah, sorry.
Yeah, you can take mine if you want. I do that.
You use mine, but it's very loud. So.
Right now, we don't really have time for playing around. Oh, where's the mouse? Yeah, you can plug it in here. I try to. So you can this one or?
That's the one. It's we're not.
Oh, you can't see it. No. It worked before, so therefore I didn't look. Interesting. Oh, thanks.
Cool. So recycled my slides from last year with new results in them, so I'm going to go through them quite quickly. I've got a poster and the Hanabi session is on Friday. Come along, talk about the game then. It's far too complicated to explain in a 5-minute section. Basically, it's a cooperative game where you're all on the same team. You can't see your own cards. Everyone else can see your cards though, and during your turn you can tell other players things about their cards. There are rules about what you can and can't say. Fairly large deck, and if you make 3 mistakes, the game's over. That's essentially what the game looks like in tile form. There's a card-based version and a tile-based version. The tile-based version is much nicer, but I can't take it to places because it's heavy. So there were previously 2 tracks. Mixed and mirror, which the same as last year. In the mixed track, you're playing with agents that you don't know, and in the mirror track, you're playing with agents that follow the same policy as yourself. This year, we've changed the paired agent slightly, so we've got our classics in there. So we've got Iggy, Internal, and Peers. Try and guess who created the Peers agent. VDB Paper is Vandenberg's agent from his paper. Model 1 and Model 2 are 2 previously unseen agents. Both of them are rule-based, and both handcrafted by myself. They've got some behaviours that can be exploited by the agents if they know what they're doing. So the results. So the mixed results, it's still actually running on our compute cluster. Oops. But they will be hopefully done by the end of the day. It was on 9,000 out of 10,000 when I checked at lunchtime, so I will put those on the website. Results that are actually in though. Mirror results, Hop Shackle, who was last year's winner, 21.30. And Rodrigo, who's from NYU, 18.83. This is across the 2, 3, 4 and 5 player variants. These are mean scores over 250 different deck orderings. And then these are our sample agents we provide. More interestingly, the learning track is 250 games with completely random numbers of players and completely different policies. So between in those policies from the previous page, basically, the agents get told basically a letter, so they know a identifier for the policy, but they've got no idea what the policy is, and they basically have to try and learn how it behaves while the game's going on. That's our agent pool. I'll put these slides online. It's essentially the same pool as before, but that's the IDs that they each had. And these are results from the learning track. Much, much harder problem. So 11.2 for Hop Shackle, 10.94 for Peers, which is one of our sample agents, and then Rodrigo got 10.28. And then Flawed, which is a really bad agent on purpose, got 4.6, and then Random is 4.5. It's up to 0.5. Yep, that's my email. You can find my poster in the poster session and our session on Friday. Okay.
Well, hello everyone. So we're now basically having a panel discussion in the middle to mix this up a little bit. So I would like to ask our panelists, you know who you are, to please come forward and take a seat. I guess we're not having microphones for everyone, right?
We have...
Okay, GVGI, maybe you've heard of this. Well, we are a lot of authors here. In fact, I've only made 2 of the 13 slides, so I'm not really sure what I'm going to present. But what's GVGI? Probably you know already that there might be new people here that haven't been to CIG before, probably haven't heard about this. It's essentially, we have a framework and a language that essentially generates games in a more or less easy way, text-based form that is translated into that. So we have a framework with about 120 single-player games and about 80 two-player games. And essentially what you have is these arcade-like games where you control one avatar, it moves around, there are sprites that can kill you. There are all kinds of games. You have something like Space Invaders, some game where you collect butterflies, and sequence. So we have 5 different tracks for this. Not all have run for this conference. The first one that ran, and the one that got the larger number of competitions, is the single-player planning track. Those are the results already. We had 12 submissions, and essentially you see 18 there because we have 4 entries that are sample controllers. I have this gray blob over there. And the first one and the third one are essentially last year's first and second entry. So the first one is the previous year's winner. It's using some kind of genetic algorithm in combination with a map that essentially guides the search and uses best first search for the deterministic games. And the second one will be the winner of this year's competition is a closed-loop MCTS with 3 reuse. I'm going to keep it very, very short. So in planning, you have a forward model that allows you to essentially simulate possible states that you get after applying certain actions. So this is the single-player planning track. We have a second version, which is a 2-player planning track. That hasn't run this year. But essentially, we have the same kind of challenges that we have for the single-player. So we have passability, different type of games, avatar type, different inputs, different scoring systems, termination conditions, interactions, etc. Plus having another player that you play against. You play some kind of round-robin league against them. Live score using Lico2, and the games can be cooperative or competitive between the 2 agents of the game. So there are some examples there. We have a capture the flag there on the left, some Sokoban for 2 players where they have to essentially coordinate to put the boxes into the holes, and new design games like that one, which is, what's the name of that one? Beekeeper. You have some bees, and you are the player on just in front of the bees, and you have to shoot the bees of the other player. All kinds of games. As I said, 8 different games. Learning track, we remove the forward model and we just make the agents learn. So you play multiple times, you can train as much as you want in the existing games. You play multiple times, basically based on an episodic kind of training. And then when you have done that, you train in 3 different unseen games that are released just 2 weeks before the competition. You train in the levels, in 2 of the levels of those games, and then you are tested in the other 3 levels. So this year we got 3 entries for this. As you can see, TNT Bot, one agent from Jaume First University, Martin Bala, one of our volunteers. These are the results that we got. So we see here is 3 levels per game and different scores obtained during the games. I'm going to just go ahead to the next one, which is the rankings. Random wins. Yeah, this is quite hard, and we still haven't received any entry that's actually better. Again, yeah. Random is the big champion of this. Yeah. We honestly, as we were saying before, and here also in the panel, we need more participants. We need more people trying to do this challenge. Well, here pretty quickly, we have 2 PCG tracks in which what we do essentially is to create content for many games. So in the level generation track, which is run by Ahmed and the NYU team, what we do essentially is to run a generator that creates levels for any game that is given. We didn't receive many submissions, completely 1 or 2. So essentially we didn't run the competition. But we have results from a previous run. So we ran this in last year. But just to show you a few ideas, essentially what we're having here is constructive techniques, very, very clear cellular automata, very predefined techniques that create structures in the levels that basically make something appealing to the eye for the judges to decide which levels are better. Different evolutionary techniques, like for instance, feasible and feasible tube population. And in general, the winners, in this case, was Architect, which generates levels like this one, have this not a lot of objects around, and it looks like something that a human could have generated. Okay, and the last one is the rule generation track. We didn't run this either, but essentially what it has is that you have a generator that generates the rules for a game, given a set of sprites that are available. I don't know how many entries have we had in the history of the rule? 0. Okay. Well, it's still a challenge there to be...
Why is random not submitting?
Yeah.
We lose by ourselves.
You lose, yeah. It doesn't want to be too much of an overload, I guess. Okay, so it's a very interesting challenge, even if nobody's submitting. You can hear more about it at the poster session. So we have a poster for all the tracks, and you can learn more about what are they about in a slower pace that I'm having now. So we have more at the poster, and some of the authors have authored lately and a GVGI book. So it's going to come out probably soon. I don't know if Dan is here. No, he's not. Well, it's a GVGI book. We're basically talking about different challenges that we have proposed, and we are analyzing what is the last state in all the different tracks, and what things can be improved, and what things we are still not being able to beat in the different tracks of the competition. It's going to be for free on our website, so we'll try to publicize it when it's finally ready, and then you can hopefully take a look at that and see if you can participate or want to use it for your lectures or whatever you want to do with it. And that is it. Thank you.
Hi, I'm the Hearthstone guy. So this is a joint effort of Sanos Mostagem and me. While Sanos is giving the lecture on AI, I'm supervisor of the playground for our students and for all participants of this competition. And for everybody who doesn't know Hearthstone, it's a collectible card game which looks like this for a human player. The bot gets a more console-based interface where you have access to all elements on the game board in an object-based manner. And we can, in this collectible card game, we choose 30 out of 1,000 cards. This creates our deck. And with our unique deck, we try to play against our opponents, reduce the health of the opponent by playing minions, attacking with these minions, playing weapons, attacking with our weapons, or just playing the, damage scrolls on each other. And this game has some unique challenges, why we are especially interested in it. And for once, it has a high degree of randomness. So nearly half of the cards have random effects, like if I play this, I kill a random enemy of your opponent. Or if I play it, three creatures on the board are damaged, but you don't know which creatures it will be. And another amount is this deck building aspect. So out of these 1,000 cards, just choosing 30 and being successful with it is a challenge in itself, which we didn't draw into because the current challenges is the pre-made deck playing track, in which we offer a set of 3 decks which are previously known. After submission, you will be tested on 6 decks, so 3 of them will be unknown, and you're playing mirror matches to keep it fair. The other challenge is the user-created deck playing track, which is far more easier because you can choose which cards you want to take, but you don't know the cards of your opponent, which makes it also somehow hard. So this competition is based on the Saberstone framework. The developer of this framework is also here and presented a paper on it. His name will be on the slides in a few seconds. And for the pre-made deck playing track, we had 16 submissions. Every of these agents needed to play 6 decks. Out of these 6 decks, 3 were known, 3 were hidden. So we used a single elimination tournament because the round robin tournament just took too long. Every agent has a response time of 60 seconds per move. And if we play 100 games with 15 agents against each other, it just takes too long. So the single elimination tournament finished yesterday evening. And I'm now happy to show which decks the agents used. So we had decks of different kind with different strategies involved if we ask human players. So some of them have just plain attacking moves. Some of them build up their board position and then attack later. Some try to control the opponent as long as possible to crush it later on. Also, the other decks, especially the buff paladin, is interesting because all the creatures it plays are relatively weak, and over the time they build up in strength. The miracle pirate rogue tries to trick the opponent by giving wrong signals, and the zoo discard warlock tries to remove as much cards from the opponent and of its own deck as possible. So these are the finalists, the top 4 agents that we had, and out of these agents I'm very happy that we don't have the random agent in here. So the breadth first search with multiple heuristics was relatively nice. We have 2 Monte Carlo tree search algorithms and also a pruned breadth first search. And the 4th place goes to an adaptation of the 3rd place from last year, the Tyke agent. Then the best child agent, which is a prune search, got 3rd. 2nd was an MCTS, which is also a continuation of a previous year's entry, so I can only recommend to participate multiple years in time. And the last one is the finalist, or the winner of the pre-made deck playing track is Tom Heimbrot with prune search with a lot of expert knowledge rules that he implemented, and these helped in reducing the search and make it more effective. So in conclusion of this track, the entry is improved overall in quality, which is hopefully due to us providing the code of previous year's entries. And the most frequent agent types that are successful are simulation-based search algorithms and to some part evolutionary algorithm trained evaluation functions for these. So for the second track we have, it's the user-created deck playing track. There we had 15 submissions where everybody could choose his own. And these agents just ran faster, that's why we could use a round-robin tournament. So here the Tyke agent was also entering this competition, and it was using a Jade Druid, a very common meta deck. Also a Jade Druid using Lars Wagner, which participated and won last year. Then Jinsang Bjorn Choi, the developer of Cyberstone, is participating here with a Monte Carlo graph search algorithm he presented today. And the last participant of the finalist round is Hoang Tony Nguyen with mid-range Jade Shaman and an evolutionary algorithm optimized fitness function. So he became 4th place. The previous year's 3rd place became 3rd place the second time. The 1st place got down to the 2nd place, and congratulations to the Cyberstone developer. He won the competition. So here the winning agents use top-performing meta decks, which comes to no surprise. And the winning strategies also include Monte Carlo tree search and the AI-optimized fitness functions. What we want to do next year is to run a deck drafting mode, because currently we have that each agent fixes his deck. And what I'm currently looking into is how to make it possible that agents interchange their decks in between and how to keep it fair. I will be standing at the poster. If you have any ideas how to do this, and just come to me and share them with me, I would be very happy, because I don't have too many until now. So the tracks will be updated for next year, and if you're interested in the detailed results of it, we will be updating the website after this conference. All the bots will be available, since this is a submission instruction, and you can find all additional sources like papers as well. So, thanks.
All right, so it went to the wrong desktop, I guess. There you go. Hi, so I'm Santiago Tañón from Drexel University, and I organized the MicroRTS competition. So I had a bunch of slides, but since we only had 5 minutes, I think I'm just going to see if I can drag a YouTube window there so you guys can see what the game is all about. So MicroRTS is a very simplified implementation of a real-time strategy game. Think of StarCraft, but more designed for research without all the engineering challenges. So I don't think you can understand what's going on over there, but you can see that there's things that look like circles, things that look like squares. The circles are units, imagine like fighters, like tanks or airplanes or whatever. And the squares are just buildings that can produce things, right? So the goal is a two-player game. There's a player on the bottom right, a player on the top left, which I think is losing right now. And the goal is to create a lot of units to go to the other player and destroy the other player, right? So that is what the game is all about. Let me see if I can stop this and change to PowerPoint. There we go.
All right. So the competition is basically building bots that can actually play this game, and the competition is centered around 3 separate problems. So there's 3 separate tracks. The first is what I call the standard track, in which the game is fully observable, so you can see the whole game state, and it's also deterministic. So the actions have a predefined effect. So this is the simplest setting, and the whole challenge is just the computational complexity of the game, right? These real-time strategy games have a very large branching factor, a very large state space, so just being able to play them is already very challenging. The second track is the non-deterministic track, where actions have non-deterministic effects. Like, for example, the damage that a unit does when attacking has a range. Also, when 2 units do conflicting actions, one of them at random will be executed and the other one will be cancelled. And the third track is the partial observability track, where, like in StarCraft, players can only see what their units see, right? So there's fog of war. So there's a collection of rules that I'm not going to go into details, but basically we run in a collection of maps. So this is a 2-player game. There's a lot of constraints, like players. You only have 100 milliseconds to produce moves and things like that. One interesting feature about the competition is that so we run in a collection of different maps, and some of the maps are public, and some of the maps I decide myself after the competition deadline, and I try to basically try to design maps that would break the bots, just so that is a little bit more interesting. There's 8 open maps, which are these maps here. I don't think, if you have not played the game, I don't think you can understand what the maps are, but basically here, this is a 2-player map. It's an 8x8 grid, so MicroRTS runs on a grid where every player starts with a base and a worker. So it's a very simple situation. The second map is just the same thing, but larger, 16x16. And the one on the right is basically a StarCraft map translated to MicroRTS, right? So MicroRTS can run from very simple to as complex as StarCraft games. These were also 4 of the public maps that are a little bit more complex. One of the maps in particular I'm very proud of, and it's very complicated for bots, which is this one here, where there's actually 2 games running in parallel with a wall in the middle, so you have to play 2 games in parallel. And I actually made a little wall in the middle that is destroyable, because otherwise if one player wins the game on the right but loses the game on the left, it would be a tie. So at the end you can just dig through the wall and finish off the other player. And the 4 maps that were hidden this year, I thought I was being innocent, but I broke one of the bots. So the first map is a map where you have no bases. So you only have workers, and you have to start from scratch. Second one is just a regular map. The third is just a melee map where there's no bases or workers or anything. You just start with fighting units, and you have to fight. And the last is the only tricky map that I thought would be the tricky one, but the trickiest was this one on the left, that some bots didn't even make a move. There's no base, I don't know what to do, I stop. And on the right, there's units trapped in walls. So these dark green things are walls. So there's some units that are trapped in the walls. In MicroRTS, to win, you have to destroy every single unit. So unless you build ranged units, there's no way you can destroy those units. So bots that have a hard-coded strategy that does not involve ranged units, there's no way they can actually win this map, right? So it was a little bit tricky. So we got 8 participants. This is up from 7 participants last year and 3 participants 2 years ago. So basically we have a slight uptrend. And we have participants from a collection of countries, from the US, Brazil, the UK, Germany, China, Mexico, Australia, and then the last one, Florian, who is halfway France, Japan, so I'm going to claim France and Japan. Then in addition to these 8 bots, I run 5 baseline bots. 4 are just 4 baseline bots that come with MicroRTS, and then I also entered the winner from last year, which was Tiamat, and then Tiamat last year won the standard and the non-deterministic track, and the winner of the partial observability track was entered again as a participant, so I didn't add it again. So because not all bots run in all tracks, so we had 12 bots for the standard, 6 bots for the partial observability, and 11 for the non-deterministic track. And as for the results, so here in the vertical axis I have win rate, and in the horizontal axis the games as the games evolve. And the thick orange line was the winner from last year, so that is Tiamat. So we can see that there's a lot of new bots that are very, very strong, and in particular the bot at the top got a 94% win rate, which is ridiculous. So basically won every match, and I think it tied some matches, and that's why it doesn't have 100%, which was shocking to me. I run bots one by one, so I keep adding, and that was the last one I added. So I was very happy at the beginning seeing these bots here, and all of a sudden I run that one that basically blew all of the other bots out of the water. So that bot at the top, I don't know if there's any bot developer here. That bot at the top comes from an Australia team. And basically what they do is, it is a very simple bot, but it's very effective. So it is a scripted bot, and bots have a practice time before the competition starts. So it could practice in every single map, and it can configure the script, how many workers to use, what army composition to use in every map. And just configuring a very strong script, it basically defeated all the Monte Carlo research, reinforcement learning, you name it, all the bots. So that was quite interesting to me. The other positive thing is that lots of bots actually defeated the winner from last year, so I'm particularly happy with this. But anyway, so the winner is UTS IMAS from Sydney. Second place is Mixbot, which is also interesting because Mixbot takes the two best bots from last year and has some logic to actually run both of them, get some action from both, and decide how to mix them. So it's Mixbot, and actually is significantly stronger than any of the two bots that it actually mixes. So it's interesting. And then Droplet, which was by one of my students, so I'm quite happy that it's there. So this is for the standard track. I'm not going to show you all the tracks because I don't have time. But the partial observability track, what we can see is that the dashed lines are baselines, so we barely are better than the baselines. So we're not doing very good there, but the winner is PO Adaptive by Florian Ricot, and then a baseline, and then Mixbot. So I'm going to put all the winners in the competition website since we don't have that much time. But basically, the conclusions is that year to year, the bots are getting stronger. Some of the algorithms that are actually working very, very well, except for the winner, that is different, is integrating scripts plus Monte Carlo tree search or scripts plus reinforcement learning. We are learning much, much better ways to actually make that integration. And those are the bots that are doing better in the competition, except for the winner that does something very different. And if you are considering participating next year, please participate in the partial observability track, which is the one in which we seem to be doing very, very bad. We can barely beat the baseline, so that seems to be the hardest problem. And all the results will be available in the competition website. Thanks.
Hi, this is Kyung from GIST in Korea. And this is one of the oldest competition running over 10 years. And the goal of this competition is to build an AI player for the original versions of the StarCraft. And it's based on the original version of StarCraft, and it's a bit old-fashioned, but more focused on the strategic decision-making. And the winner is the one with the highest winning ratio from the matches between AI versus AI. And we use 5 maps, and we run 40 rounds. In total, the number of games is 14,000 games. And this video shows how we run the competition. We use a tournament management software developed by Dave Churchill, and the software select 2 AI players and assign them to play a game and report the results to the web page. And in this year, we got 27 submissions, and because we allow automatic resubmission from the last year competitions, so 19 of them from the last year without any modification. Only 8 submissions are new or upgraded submissions. And regarding the race, it's highly balanced. It's like a human players competitions. Let me show you the results. And the third rank is the Locatus. Locatus was the winner of the last year. And the second rank is a MacWave. and the gap between the second and third is very small. And the winner of this year competition is Purple Wave. The winning ratio is close to the 90%, and Purple Wave by Dengen. And technically, they use a task network to make some high-level decision making, and also they use fast clustering to make a group of units. And also they develop a simple simulator to predict the outcome of the combat. And this table shows the top 10 entries of the competition, and you can see that most of them are new or upgraded players. So it means that there was some progress over the last year competitions. And all other AI players are from the last year competition without modifications. And this is a graph of the winning ratio over the round. And the winning solution starts from the 70% winning ratio, but increases continuously and converges at the 90%. And let me show you the highlights of this competition video. And there was a big fight between the players. And you can see that the Terran player advanced to the base of the Protoss opponent. In the second match, the player used very strange strategy that building the structure in a very strange place. But it was detected by the player, and they blocked the entrance of the base and tried to produce the very strong but very slow unit named as a Reaver. And actually the player delivered the Reaver unit onto opponent base and win the game. And in this match, the opponent tried to block their base, and they used a bunker, but the winner tried to produce very cloaking units named as the Dark Templar, and actually it destroyed the bunker and win the games. And actually there are lots of videos. I will show you the many videos in the post session. Okay. And I'd like to express thanks to other two international conference StarCraft AI competition organizers. Thank you.
Okay, so hello everyone. I want to present you the results and the competition stuff about the strategy card game AI competition. It's barely new competition. It's kind of first or second edition, including CC this year. So it's about the collectible card games. It's a card game which has two phases. One is a draft. You can know it as an arena from the Hearthstone. Like you do not have the deck building phase, like you choose from these thousands cards your own meta decks, but you have proposed 3 cards and you have to choose best and do it like 30 times. And of course there's a battle phase which is kind of similar to Hearthstone. I'm very thankful that I don't have to explain the rules of the game. And okay, this is very interesting topic, as Ami already said. The Hearthstone stuff, it's kind of an interesting. But we have a Hearthstone AI competition. But the point of this competition is kind of, I would say, similar like micro